Hello learners, I am Dr. Nidhi Singh. Today we are going to talk about Earth's interior and its material. So in this session we will be talking about Earth's interior, secondly materials that form the Earth's surface, types of rocks and economic significance of rocks. So first of all we would like to talk about Earth. The Earth is the only planet which has developed life. It's spherical in shape and the land features do not retain their fixed form. Instead, their shape is constantly changing. How come these shapes are changing on the Earth's surface of all the landforms? So, there are two forces that are responsible for that. One is the exogenetic forces and the other is endogenetic forces. Exogenetic forces act on the Earth's surface, that is above the Earth's surface, while the endogenetic forces are acting on the area below the Earth's surface, that is inside the Earth's surface. These two forces, exogenetic as well as endogenetic forces, they result in disintegration of rocks, shaping new landforms, and there is formation of soil with these two forces itself. Now, we'll talk about Earth's interior. It's impossible to know what is there inside the Earth's surface with direct observation. So, what are the reasons for that? One is that it has a huge size. So, it's not possible to go inside and then see what's there inside the Earth's surface. Secondly, there is rapid increase in temperature below the Earth's surface, and this can melt even the hardest of the drilling tools that if we send there. So, because of these two reasons, it is very difficult to observe what is there inside the Earth's surface with direct observation. Now, the structure of Earth's interior. So, the Earth's interior has different layers and it is in the form of concentric layers. Concentric means there is one center and then there are rings. So, of all the circles there is a single common center. So, for Earth also there is one center and then different layers are there one after the other in a concentric ring form, like just like an onion. You can see in the picture the Earth has different layers in the concentric ring form. Its core, mantle and the crust. Now, there are three layers of Earth. One is core, that is the innermost layer. Second is the mantle, the layer above the core, and then crust, the outermost layer where we all live in. So, it's from inside to outside, it's core, mantle and then crust. Now, first of all, we will be dealing with core, that is the innermost layer of the Earth's surface. This is the innermost layer and it ranges from about 3500 kilometers in radius. It is the densest layer where the density ranges from 9.5 to 14.5 or more. It is composed of iron and nickel and therefore it is known as knife. Extends from center of the Earth to 2890 kilometers. There are two sublayers of core. One is inner core, that is solid in nature, and another one that is outer core, that is semi-liquid in the nature. You can see in the picture also. Now, the second layer is mantle. Mantle surrounds core. It is a rock shell which is about 2900 kilometers thick. It is composed of basic silicates. Its constituent elements are magnesium and silicon, that makes it SEMA. Its density varies between 3.3 to 5.7 and it extends from 2800 kilometers to 100 kilometers from inner side to the outer side. You can see in the picture again. The third layer is crust or the outermost layer. It is also known as lithosphere. The density of this layer varies from 2.70 to 2.95. Its constituent elements are silica and aluminium. So, it is also called Sial. It is the outermost part of the lithosphere and it is also known as crust and it ranges between 8 to 40 kilometers. So, you can see the diagram in this again. The outermost layer is called Sial and it is also called crust and lithosphere. Now, we will be discussing about the temperature of Earth's interior. There is rise in temperature with increase in depth. The evidences which are responsible for this, from where we can find out that how temperature rises with increase in depth, is that mines and deep wells, then molten lava erupting out of the earth's surface. So when we go inside deep mines and wells, we feel little hotter. And secondly, another evidence is that molten lava comes out of the earth's surface, from inside the earth's surface to the earth's surface. So the observation shows that the rate of increase of temperatures is not uniform. So for the first 32 meters, the rate of increase is 10 degrees centigrade, while so it can be said that while for 32 meters it's 10 degrees centigrade, then for 10 kilometers inside the earth's surface it can be 3000 degrees centigrade, and further down it can be 12,000 degrees centigrade or more than that. But this is estimated, that we have estimated, but in reality this is not so. Why? Because otherwise if this would have been the case, the earth would have been in a molten state, but this is not the case. Why this is so? Because the rocks buried under the pressure of several kilometers of overlying rock melt at higher temperature than the surface rock. So when there is lots of pressure inside the earth's surface because of the overlying pressure, overlying material, so what happens that because of pressure the rocks, they do not melt easily, they have higher density and they do not melt. So therefore earth is not at all in the molten state, the whole of the earth inside is not in a molten state. Now another evidence to show that there are different constituents that form the earth's interior is the behavior of earthquake waves. With the help of earthquake waves, we can find out that there are different kind of material present inside the earth's surface. Some are denser, some are less denser, and so the behavior, the manner in which they are deflected, the earthquake waves are deflected, they show the constituent of the earth's interior. The rate of increase of temperature beneath the surface also varies depending upon the constituent of the material. So, for the upper 100 kilometer, the rate of increase of temperature is 12 degrees centigrade per kilometer. For the next 300 kilometers, it is 20 degrees centigrade per kilometer, and for below that it is 10 degrees centigrade per kilometer. So, pressure is also there which is acting here for changing the rate at which temperature is increasing, and as well as the density of the material inside the earth's surface. Now pressure, another aspect that we study inside the earth's surface, the pressure. It increases from the surface towards the center of the earth. The reason is that there is huge weight of the overlying rocks. So the molten material is under tremendous pressure. It acquires property of a solid, probably a plastic state. So what is plastic state? Plastic state is not exactly solid but not exactly liquid also, semi-liquid kind of state is there. Now density, another aspect which we study inside the earth's surface, it again increases with pressure. So the density also increases with the depth. There is a presence of higher material towards the earth's centers. So the density of earth's layer also goes on increasing. The materials of the innermost part of the earth is very dense. So temperature, pressure and density, all three aspects increase when we go inside the earth's surface or when we go deep into the earth. Now what are the materials that are found on the earth's crust? So the material of the earth crust is made up of rocks, and rocks are made up of minerals, and minerals are made up of elements in a definite ratio. So elements make minerals, minerals make rocks, and rocks make the uppermost crust of the earth's surface. Now the crust has more than 2000 minerals, out of which 6 are the most abundant minerals that are found on the earth's crust, and these are feldspar, quartz, pyroxenes, amphiboles, mica and olivine. So these all minerals are the most abundant minerals found on the earth's crust. Now when we are talking about the minerals and rocks, we should know that what are the different types of rocks. On the basis of mode of occurrence or mode of formation, there are 3 types of rocks. One is igneous rock, second one is sedimentary rocks, and then third one is metamorphic rocks. Now we will be dealing in detail what are these rocks, how are they formed, what are different types of these rocks and so on. So first of all, igneous rock. Igneous rocks are formed by cooling of molten material called magma. When magma is deep seated inside the earth, it's known as magma, and when it comes out of the earth's surface, it's known as lava. Magma comes out in the form of lava, it cools down and it forms igneous rocks. You can see in the diagram also that magma is coming out, it's known as lava, and then it cools down and then it forms igneous rocks. So, magma is formed around 40 kilometers deep inside the earth's surface, and then it comes out and it's called lava. Now, igneous rocks comprise of the earth's surface mainly. All other rocks are derived from them. Therefore, igneous rocks are also known as parent of all rocks or the primary rocks. 95% volume of the outermost 16 kilometer of the earth is made up of igneous rocks. Now, there are different types of igneous rocks also. On the basis of mode of occurrence, there are extrusive igneous rocks and then intrusive igneous rocks. Extrusive igneous rocks are formed by cooling of lava on the earth's surface. So, when the lava reaches the earth's surface, then it cools down quickly, very rapidly. So, because it's in contact with the atmosphere, and so the mineral crystals that are formed are very fine. These are also called volcanic rocks, and the examples are gabbro and basalt. Basalt, you can see a picture of basalt in the slide. Now, these are mainly found in the volcanic areas. For example, in India, Deccan Plateau's regular soil in India is derived from lava, and the Deccan Plateau is a result of igneous activity, and igneous rocks are found and abundant in the Deccan Plateau. Now, you can see different types of igneous rocks in the slide or in the picture given. Extrusive rocks are there, intrusive rocks are there, and various other types of intrusive and extrusive rocks are given in the picture. Now, the second type of igneous rock is intrusive igneous rocks. These are formed when magma solidifies below the earth's surface. So, the cooling is slower, it is not directly in contact with the atmosphere. So, the granules that are found or the crystals that are formed are large in number. Sometimes we can see even with our naked eyes also. So, some of the common forms of intrusive igneous rocks are batholiths, sills and dikes. Batholiths are dome shaped, sills are horizontally formed, and dikes are vertical in nature. Some of the examples are granite and dolerite. You can see the picture of granite. Granite is commonly found in our kitchens and various other, in our houses also, in shops and everywhere. So, in granite, if you observe, the crystals are not very fine. We can see them with our help of our open eyes also, naked eyes also. So, there are two types of intrusive igneous rocks also. One is plutonic rocks that are deep seated intrusive rocks, and then hyperbasal rocks that are found at shallow depths. Now, different forms of intrusive igneous rocks you can see in the picture. First is batholith, that is dome shaped. Second is sill. You can see the horizontal banding. The dark color rocks are sill, found igneous rocks that have been intruded into the existing rocks. And then the third one is the dike, that these are vertical in nature. The dark color igneous rocks you can see are the dikes that have been, when the lava get intruded into the existing rock, and then dike was formed. Now, on the basis of chemical properties also, there are different types of igneous rocks. One is acidic rocks and another one is basic rock. What are acidic rocks? These are formed of acidic lava. These are composed of 65% or more of silica, and these are light in color, hard and very strong. Example is granite. You can see another example of granite in this picture. You can see the crystals very easily in this. Another one is basic rocks. These are formed of solidification of basic lava. It is composed of less than 55% of silica, more of iron and magnesium. These are dark in color and weak, so they are easily weathered. Examples are gabbro, basalt and dolerite. You can see the example of basalt in the picture. Another type of rock, major categorization, is sedimentary rocks. So, what are sedimentary rocks? These are formed by successive deposition of sediments. What are sediments then? This is the debris eroded from any previously existing rock, and any previously existing rock can be igneous or metamorphic in nature, or a old sedimentary. A pre-existing sedimentary rock can also be eroded, sedimented, and then sedimentary rocks are formed. The sedimentary rocks have a very peculiar characteristic that these have stratifications or layers. So, therefore, they are also called stratified rocks. The thickness of strata varies from few millimeters to several meters. One of the best example of sedimentary rocks is yellow sandstone is widely found in Rajasthan, and you can see several buildings, several houses made up of yellow sandstone. Red sandstone is also widely found in India, and Red Fort and various other forts are made up of red sandstone. Now, another very important characteristic of sedimentary rocks is that they contain fossils. What are fossils? These are the solid part of an impression of a prehistoric animals or plant embedded in rocks. So, this can be solid part of any plant or animal, or impression of that, or a pre-existing plant or animal. So, these are found widely spread on Earth's surface at shallow depths. In the slide you can see the picture of fossils. So, these are fossils of marine animals which have been embedded in sedimentary rocks. Now, some of the examples of sedimentary rocks, as already mentioned, sandstone, shale, limestone, coal, dolomite, and several other several other rocks are also there. The process of formation of sedimentary rocks can be seen in the diagram. First is disintegration of rocks, that is already existing igneous, metamorphic or sedimentary rocks. Then these disintegrated rocks are result in sediments. Then these sediments are transported through water, glacier or wind. So, transportation of sediments takes place, then deposition or sedimentation takes place, then compaction or cementation takes place, and then sedimentary rocks are formed. Various folded mountains of the world like Himalayas, Andes, etc. are formed of sedimentary rocks. Now, the third major categorization of rocks is metamorphic rocks. Metamorphic rocks are formed under influence of extreme heat and pressure on sedimentary or igneous rocks. So, when extreme heat or pressure is subjected to any igneous or sedimentary rock, then metamorphic rocks are formed. You can see in the diagram, when existing rocks are subjected to extreme heat and pressure, there is change in color, structure, composition and hardness. This whole process of change is known as metamorphism. So, existing rock is subjected to heat and pressure, metamorphism process takes place, and then metamorphic rocks are formed. Examples of metamorphic rocks are slate, gneiss, schist, marble and diamond. Now, there are two types of metamorphism, that is the process through which metamorphic rocks are formed. One is thermal or contact metamorphism, as you can see in the diagram, and then second is dynamic or regional metamorphism. The first one, that is thermal metamorphism, is the process of change by heat, while the second metamorphism is process of change by tremendous pressure. So, what happens is magma comes out in the form of lava, and then there is contact with surrounding rocks. This lava bakes them and changes their shape, color, hardness, etc., and then metamorphic rocks are formed. These are some of the examples how parent rocks change into metamorphic rocks. So, some of the examples are given in the slide. You can see that limestone or dolomite changes to marble, sandstone, which is a sedimentary rock, changes or metamorphosized into quartzite, shale gets metamorphosized into slate, slate then further gets metamorphosized to phyllite and schist, and then it further gets changed into schist. Coal gets metamorphosized into graphite or diamond, and then granite changes into gneiss. picture that you can see is of marble rocks. Marble rocks are widely formed in Rajasthan as well as in MP also. So the Bheda Ghat, famous Bheda Ghat of Madhya Pradesh has abundant of marble rocks. Now the occurrence of metamorphic rocks, marble as mentioned earlier again is found in Rajasthan, Bihar also and Madhya Pradesh. Slate is found in Orissa, Andhra Pradesh and Haryana. It is also found in Kangra and Kumaon regions of Himalaya in different colors. In picture you can see Taj Mahal, which is made up of white marble rocks, and these are metamorphic rocks. After discussing about various types of rocks, now we will be discussing about economic significance of rocks. So the first and most important significance of rocks is that soils are derived out of them. So soil provide the basis for growing food and crops. So we are directly or indirectly dependent on soil, and it also helps in providing raw material for many industries. So soil provides a base for growing food as well as raw material for various other industries. The second important significance of rock is it provides building material. So it is a source of building material directly or indirectly. For example, granite, gneiss, sandstone, marbles, slates, etc. are used in construction purposes. Taj Mahal, as mentioned earlier again, is made up of white marble. Various other forts and buildings and houses are made up of yellow sandstone, red sandstone, and historically now we use cement, but earlier people used to use these locally available rock materials only. For example, yellow sandstone, red sandstone were used for building purposes. Then red forts of Delhi and Agra are made up of red sandstone. You can see in the picture, yellow sandstone building is also there, and then red sandstone building is also there. Then slates are used for roof purposes in various areas because they are locally present or available there. Now the third economic significance of rocks is mineral source. They provide the mineral source for various, which are further used in various industries. The foundation of the modern civilization started with mineral resources. Iron, copper, aluminium, gold, etc. are derived from rocks. So the Iron Age is known for discovery of iron and use of it, and similarly copper and various other minerals were used for formation of tools, and civilization were based on that. Then fourth important economic significance is that it provides raw material for various industries like cement industries, and then graphite is used for crucible and pencil manufacturing. In this picture you can see there are three different pictures. One is of iron ore. So this is iron ore which is used for in various industries for various purposes. Graphite, the commonly used thing of graphite, made up of graphite, is our pencil. So pencils have graphite in them. Then gold is there, we use ornaments, and gold is used for various other purposes in several industries and for chemical processes also. So these are some of the economic significance of the rocks. Another economic significance is precious stones. Various precious stones are derived from metamorphic and igneous rocks, and for example diamond, gems, rubies and sapphire. Another, the sixth important significance of rocks is that various fuels are derived from these rocks. For example, coal, petroleum, natural gas and nuclear minerals are also there, which are used for creating electricity, generating electricity, and these are used in houses, then industries and various other purposes. Fertilizers are also derived from rocks. Phosphate fertilizers are derived from phosphorite minerals, and these are widely used in growing food. So in this session we learnt about Earth's interior, different layers of the earth, core, mantle and crust, then different materials that the earth's surface is formed of, different types of rocks, igneous rocks, sedimentary rocks, metamorphic rocks, various characteristics of these rocks, various subtypes of these rocks, and their economic significance, which is helpful in our day-to-day life. So I hope you must have understood and learned the session and the various things talked about in this session. Thank you.